Hey, have you ever wondered how the universe is constantly changing? Imagine witnessing a cosmic event so powerful, it could impact your daily life in ways you never thought possible. This might just happen sooner than you think, and you could be one of the few to experience it before it happens again in billions of years. Tonight, we delve into the fascinating and potentially alarming scenario. What if a solar storm hits Earth? Should you be worried, or is it just another wonder of the universe? Stay tuned as we explore the science, the history, and the real-world implications of this extraordinary event. Solar storms, or geomagnetic storms, are disturbances in Earth's magnetosphere caused by solar wind. The most powerful storms are triggered by coronal mass ejections, CMEs, which are massive bursts of solar wind and magnetic fields rising from the solar corona. CMEs occur when the sun's magnetic field lines rearrange and release large amounts of energy. This process expels billions of tons of plasma into space, traveling at speeds up to 3,000 kilometers per second. When these ejections are directed towards Earth, they can interact with our planet's magnetosphere, causing geomagnetic storms. The creation of solar storms begins with sunspots, which are regions on the sun's surface with intense magnetic activity. These spots are cooler than their surroundings and appear dark in contrast. Sunspots are often precursors to solar flares and CMEs. The current concern stems from a massive sunspot cluster recently observed on the Sun. This cluster is estimated to be 17 times wider than Earth, significantly increasing the chances of a solar storm affecting our planet. Predicting the exact timing and impact of a solar storm is challenging. However, satellites such as the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, continuously monitor the Sun's activity. When a CME is detected, it usually takes between 1 and 3 days to reach Earth, traveling at an average speed of 800 kilometers per second. The U.S. National Oceanic and Atmospheric Administration's, NOAA, Space Weather Prediction Center plays a crucial role in issuing warnings. They alert operators of power plants and spacecraft to take precautionary measures and advise high-frequency radio users to expect possible signal disruptions. Geomagnetic storms can have profound effects on modern technology. Power grids are particularly vulnerable due to the induced electric currents caused by fluctuating magnetic fields. These currents can overload transformers and other infrastructure, potentially leading to widespread blackouts. For example, the Halloween storms of October 2003 caused power outages in Sweden and damaged satellites, illustrating the significant impact of such events. Even long pipelines can become electrified, leading to engineering issues and potentially dangerous situations. Satellites orbiting Earth are also at risk during solar storms. High doses of radiation can damage the delicate electronics on board, disrupting communication, navigation, and weather monitoring systems. Spacecraft in orbit need to take precautions, such as powering down non-essential systems and reorienting their solar panels to minimize damage. Air travel, particularly on polar routes, can be affected as well. Increased radiation levels can pose health risks to passengers and crew, and airlines may need to reroute flights to lower latitudes to ensure safety. The biological effects of solar storms extend beyond technology. Animals, such as pigeons, which navigate using Earth's magnetic field, can become disoriented during geomagnetic storms. Studies have shown that these storms can interfere with the internal biological compasses of various species, leading to unusual behaviors and migration patterns. Some researchers even suggest that strong geomagnetic storms could impact human health, potentially increasing risks for astronauts in space and affecting those with certain medical conditions on Earth. Historically, the most powerful geomagnetic storm on record is the Carrington event of September 1859. This storm caused widespread telegraph outages and even fires due to the induced electric currents. Auroras, typically seen near the poles, were visible as far south as the Caribbean. More recently, the aforementioned Halloween storms of 2003 demonstrated the disruptive power of solar activity in our modern, technology-dependent world. These historical precedents highlight the potential for significant impact and underscore the importance of preparedness. The awe-inspiring displays of the northern and southern lights, known scientifically as auroras, are among the most visually striking effects of solar storms. These lights are produced when charged particles from the sun collide with atoms in Earth's atmosphere, causing them to glow. During strong geomagnetic storms, auroras can be seen much further from the poles than usual. Social media often lights up with stunning images of these celestial events, shared by people around the world. In Hartford, England, for instance, Ian Mansfield recently shared his excitement on social media after witnessing the northern lights in his backyard. In Tasmania, photographer Sean O'Riordan captured breathtaking skies and shared them online, garnering widespread attention. While the beauty of auroras can inspire wonder, the potential disruptions caused by solar storms necessitate serious consideration and preparation. Governments and agencies advise having contingency plans for communication and power disruptions. This includes ensuring backup power supplies for critical infrastructure, such as hospitals and emergency services, and developing strategies to quickly restore power in the event of a blackout. The NOAA Space Weather Prediction Center provides crucial information and alerts, helping society prepare for and mitigate the impacts of solar storms. Solar storms also offer an opportunity for scientific research and international collaboration. By studying these events, scientists can better understand the complex interactions between the Sun and Earth's magnetosphere. This knowledge can improve predictive models and help develop more effective protective measures for our technology and infrastructure. International cooperation is essential, as solar storms affect the entire planet. Sharing data and resources can enhance our collective ability to monitor and respond to these cosmic events. The dynamic nature of the Sun serves as a reminder of the powerful forces at work in our solar system. While we cannot control solar storms, we can prepare for their potential impacts. Understanding the science behind these phenomena, studying their historical precedents, and developing robust contingency plans are essential steps in safeguarding our technology-dependent society. The potential for awe-inspiring celestial displays, such as auroras, adds a sense of wonder to our preparations, reminding us of the beauty and complexity of the universe. In conclusion, the question of what if a solar storm hits Earth is both a scientific inquiry and a practical concern. Solar storms, driven by CMEs, can disrupt technology, affect biological systems, and create stunning visual displays. Historical events like the Carrington event and the Halloween storms of 2003 highlight the potential impact of these phenomena. By leveraging modern monitoring systems, such as SOHO and SDO, and heeding warnings from agencies like NOAA, we can prepare for the challenges posed by solar storms. As we continue to study and understand these cosmic events, we are better equipped to protect our world and appreciate the wonders of the universe. Our journey into the possibilities and preparations for solar storms underscores a vital truth: the universe is a dynamic place, full of both peril and beauty. As we gaze into the night sky, captivated by the shimmering auroras, we must also respect the underlying forces that can shape our world in an instant. Solar storms remind us of our place in the cosmos, as well as our ability to understand and adapt to its ever-changing nature. So, next time you look up at the stars, remember that the universe is always in motion, and we are a part of its grand dance.